Hi. Today I'm going to prove that log of a on the base b equals log of a divided by log of b. To do that, we're going to have to recap a little bit of the properties, at least one property of logarithm and what logarithm means. So when you have y equals log of a divided on the base b, what does that mean? That means that b elevated to a, or to the power of a, b to the power of y equals a. Okay, so that's what it means to have y equals log of a on the base b. That means b to the power of y equals a. Got it right here. Now, let's just say that you know that the base is b of the logarithm. Let's just say that you get another b, all right, and you take this b to the power of log of a to the b. What does that mean? That means that these two bases here are the same, b and b. So it's b to the power of log of a to the b. But what is log of a to the b equals y? So b to the power of log of a on the base b equals b to the y. And what is b to the y? Equals a. All right? So this is a property of logarithm. When you get something and you take that to the power of log of anything on the base something, that's going to be equals to anything. That's crazy, I know, but here we go. We got a 7 here, okay? Now, what is another way to write the 7? I just picked the base, which is s. It can be t, z, v, omega, it doesn't really matter. Now, you have this s base here, and you take it to the power of log of 7 on the base s. Okay, so the bases are the same. You got an s here and an s here. The bases are the same, so the whole thing here equals 7, right? It's the same thing that happened over here. For example, 22, another example, 22. What's one way of writing 22 on the base c of logarithm? Well, you get a c and you take it to the power of log of 22 on the base c. So these two bases are the same. This whole expression right here is going to equal 22. And you got the 22 right here. Okay? Now, knowing this property, logarithm, here we go. You got here log of a on the base b equals log of a divided by the log of b. I'm gonna do something. I'm gonna divide the sides in here, because everything that I do on one side, I'm gonna have to do on the other side. Okay? Now what I'm gonna do is I have this base b in here. I'm gonna take this base b and I'm gonna take it to the power of log of a on base b. These two bases are the same, so the whole thing equals a, right? This side is done. Now if I can turn this side over here into a without breaking any mathematical rules, that proves that the two sides are the same. So I did it to this side, I have to do it to the right side too. I gotta do b to the log of a divided by the log of b, right? Now here's the thing. I'm gonna write this b here, this base, in a different way. I'm gonna write it in the power of 10, okay? So how's this gonna work? I'm gonna put a 10 here. I'm gonna say 10 to the log of b. Why am I doing this? Because there's a base in here. Whenever the base doesn't show up, okay, there's a base hidden in here. Whenever the base doesn't show up, it's because it's 10. So you got a 10 here and you got a 10 in here. So the bases are equal, 10, 10. The whole thing equals b, okay? Equals this b right here, this one, right? Okay, now this b here is elevated to the power of log of a divided by log of b. So we gotta take this whole thing here to the power of log of a divided by log of b. It's pretty tight in here. Well, that'll just have to do. You're gonna have to multiply these exponents, these powers. So log of b here and log of b here, you can just cancel them out. What are you left with? You're left with 10 to the log of a. Okay, now what did I say? That when you don't have a base showing up here, it's because it's 10. So this one is 10 and this one is 10. The whole thing equals what? A. So I proved that this side equals a and this side equals a. Therefore, this side, whatever happens on this side, equals whatever happens on this side. Okay, so that proves that log of a on the base b equals log of a divided by log of b.